Welcome to the design and analysis of algorithm laboratory. Today we are going to learn about the program number 2, that is design and implement a C or C++ program to find a minimum cost spanning tree of a given connected undirected graph using Prim's algorithm. Okay. So first, what is the main objective of this program is to find a minimum cost spanning tree. In a given graph, we have to find a minimum cost spanning tree. First, let us know what is the meaning of a spanning tree. What is spanning tree is it's a subgraph of a graph which consisting of all the nodes but not all the vertices. Meaning of that is if I consider a graph with nodes, all five nodes should be present and all should be connected, then that type of graph are called as a spanning graphs or spanning trees. Then what is minimum cost spanning tree is, for example, if I consider a graph with a cost matrix, in that cost matrix, I should select a edge in such a way that whenever I calculate or I add all the edges that has been selected as a spanning edges, then that should be a minimum cost. That then we call them as minimum cost spanning tree. So what is spanning tree? Where you should have all the nodes but not all the edges. Whenever I start from any of the node, all should be connected. Meaning of that is all should be reachable. Then that property is called as a spanning tree. And if I select a minimum edge or an edge with a minimum cost, then that we call them as a minimum cost spanning tree. Okay. First, let us learn one of the example. Then we will go for a program. Yeah. What is minimum cost spanning tree? See, if I consider this, we have three nodes, 1, 2, and 3. We have edges. Okay. It should be a undirected graph. Then if I consider this, if I start from 1, I can select 2 and 3. Okay. This is a undirected graph. There are two edges we have, correct? So either it can be from 1 to 2 or 2 to 1. Here also it is from 3 to 2 or 2 to 3. Here also from 3 to 1 or 1 to 3. Okay. It's undirected graphs. So whenever I start with 1 now, okay. If I consider this 1, what is spanning tree? I should have all the nodes. First, I consider 1, then 2 and 3. Which are the edges that are connected? I can select either from 1 to 2, then 2 to 3. Okay, 2 plus 3, 5 we got. Okay, another possibility we have is 1 to 3, 3 to 2. What is the edge we have selected? We have selected the edge from 1 to 3, then we have selected edge from 3 to 2. So 10 plus 3 is 13. Whether 5 is less or 13 is less, 5 is less. Like this, we have to select the edge in such a way that it should be a minimum cost. Okay, this is a simple example we have taken. Okay, we'll just solve one of the problem we have, then we will go for a program. Okay, consider this particular graph where it has a multiple nodes and multiple edges. Okay, we can start with any of the nodes that we have. There is no condition that you should select from S, A, B, C, D, E, D. You can select any of the node as starting. Then you can go on traversing. Okay, now we'll just solve this problem. Well, how to solve this problem? We'll start from S. Let us take S as a source node. So if I start with the S as a source node, what are the directed edge we have? Okay, the edge that is having with the S. S we have from S to A, we have 12. S to B, we have 8. We does not have any other edge. Okay, we have only two edges for S. One is to A, second one is for B. Okay, so S to A, what is the cost we have associated with this particular edge? It is 12. What is the cost associated with this B? It is 8. Which is lesser? B is lesser. S to B is lesser. So we have to select the edge as S to B. This is the first step. Okay. Now S is visited, B is also visited now. Okay. We have to make a visited one. So once we visited, we should not visit the edge particularly again. Why? Because if I select again, then it's not a spanning tree. Only once you should visit that particular node. Okay. Now we are in which node? B node. Okay. From B, which are the edges we have? We have for S, we have for A, we have for C, we have for E. We should not select S because it has already been selected. We have for A, select. We have to check. For E, we have to check. For C, we have to check. If I select for A, what is the cost associated with this? 9. For this, it is 14. For this, it is 16. So, according to this 19, 16 and 14, which is lesser? 9 is lesser. So, we will select that particular edge. So what is a spanning tree? S to B, B to A. Okay, now we are in which edge, which particular node? A node. Now again we consider what are the edges we have from A to C, A to E, A to S, A to B. S should also be not be selected, B should also not be selected because it has already been visited. Either we can go for C or E. If I consider this, what is the cost associated with C? 22. For this, it is 11. Which is lesser? 11 is lesser. So we will select that particular 11. Now we are at which node? E node. Okay. If I consider E node, what are the edges associated with E now? E to A, E to C, E to D, and E to B. B should also not be selected. It has already been visited. A should also be not be selected because it is already been visited. Then we have for C and D. Okay. Now the cost associated with E to D is 3. E to C is 18. Which is lesser? This 3 is lesser. So we will select that particular 3. Okay. This is my fourth step. Okay. Last one we have for D now. From D, which are the edges we have? We have for C. We have for E. E should not be selected because it has already been visited. Which is the only edge that is left of 50. So that is selected. Okay. Kindly check whether the condition for spanning tree is satisfied. What is spanning tree? All the nodes should be present. How many nodes we have in the actual graph? This is my actual graph. How many nodes we have? 1, 2, 3, 4, 5, 6. All the nodes are present here. Yes, A, B, C, D, E, all the edges, all the nodes are present. Then we should, whichever the node that you select, from that particular node, all the nodes should be visited. If I start with yes, B is reachable, A is reachable, E is reachable, D is reachable, C is reachable. If I consider A, all the nodes are reachable. If I consider B, all the nodes are reachable. If I consider E, all the nodes are reachable. If I consider D, all the nodes are reachable. Then if I consider C, all the nodes are reachable. Okay. So this is spanning tree. What is minimum cost spanning tree? In the existing one, the edges we have selected with a minimum cost. So that is called as a minimum cost spanning tree. Now we will just go for a program. Here we will take the visited node that should be taken because we want to identify the node that has already been visited. Because once the particular node has been visited, we should not visit it again. And we have a minimum cost. Initially it is 0 cost, that is the cost associated with each and every edge. First we have to enter the number of nodes. Okay, in the previous example, if I consider how many nodes we have 4 plus 2, 6 nodes we have. We will specify the 6 nodes. Then adjacency matrix or a cost matrix we have to enter, we will enter. Okay. Then we have to initialize the first node. Here, which is the source node we have, the first node is a source node. We have made it as 1. So that particular node has already been visited. Okay. Now we have to calculate for all the other nodes which are other than the source nodes. Okay. If NE is less than N, then we will start doing this. What is this NE? It is negative. Meaning of that is that has not been initialized or not been visited. Okay. Only the first node has been visited. Other than that, all the nodes are not been visited. Okay. So NE is 1 now. What is the number of nodes? 6. NE is less than N. So it will enter here. Okay. We will start with I index as 1. Okay. 0th index is already been visited. We will start with 1. Now we'll start with cost of ij. What is cost of ij? That has been given in a matrix. So if that is less than the minimum we have taken as 999. Then if it is not visited, then we will assign that particular minimum to cost of ij. What is this U and V? Okay. This is very, very tricky part where U and V represents from node and to node. What is this U and V? I will just know. Okay. So if I consider this particular one, okay, A to B, from which node we have started? B. From which node we have ended? A. So U will be B, V will be A. Okay. Cost associated with this 9. Initially, this has all been initialized to 999. We'll check with 9 is less than 999. If it is true, then it has not been visited. A is not been visited. Then we will select this H. The same condition is specified here. What is the condition we have specified here? If it is not visited and the cost is less than minimum, then we will assign that as minimum of that. Then we will assign U to the A node, B to the V node. Then we will select that particular edge. Okay. Once this visited of U equal to 0 or visited of V equal to 0. How these conditions work? Okay. Please see this. If I consider the first initial condition. Okay. If I consider this first initial condition, which has been visited. Okay. This, if I consider S and B. Okay. B, let us consider B has not been visited yet. Okay. Now, for the first one we have, that is S only visited. Okay. Either U has been visited or U or V has been visited. Here U is A. This is the S. That is U is S. V is B. Okay. Either of them has not been visited, then we can select a H. For example, when this condition fails, okay, we will see it. Okay. Kindly consider this particular example. Now, if I consider S to B, okay, we have selected this H. Now, from B, we have A, we have to S, we have to C, we have to E. Okay. If I want to consider B to S, whether we should consider, we should not consider. Why? Because S has already been visited. How to identify that is by this condition. Either of the node should be unvisited, then only we can visit that particular edge. Okay. If this condition taken here, S is also been visited. We have selected as first one only. B has also been selected in the first step. B has also been selected in the first step. So B is also visited. S is also visited. So we should not consider this particular edge in any of the further transactions. To specify that condition, we use this. Okay. So for that condition, we use this particular one. Either one of the nodes is unvisited, then only we can visit that particular edge. Otherwise, we should not edge. Okay. If we does not get any of the edges, then we will specify that as 999. That is the maximum value. Otherwise, we will specify the minimum cost will be this one. We will add every other vertex to every other vertex, then we will identify. This is just the output of that particular Prim's algorithm. Enter the number of nodes 4. This is a matrix. Okay. So whenever we enter the matrix, if you have a edge, whatever the cost associated with that, otherwise 999. Okay. So this is a edge 1 to 2 cost is 1, 1 to 4 cost is 2, 4 to 3 is 3. So we will add all these things. 3 plus 2 5, 5 plus 1 is 6. So minimum cost spanning tree is this one 6. This is the program for Prim's algorithm. We'll see in the next program the Kruskal's algorithm. Thank you.